Title of the first section today is Graphing, Quadratic, Inequalities. Graphing quadratic inequalities, instead of an equal sign, we'll have an inequality for the equation. First question, y is greater than or equal to x squared plus 3x minus 18. There are several ways to graph this problem. We can either use the equation negative b over 2a. We can also try and factor it. We could use a t-table or any of the other methods. For this question, we can find the vertex by using negative b over 2a. Negative b would be negative 3 divided by 2 times a, and a would be 1. So the x value of the vertex in this question would be negative 3 over 2. Plugging this back in, we can solve for y. X squared, or negative 3 over 2 squared, plus 3 times negative 3 over 2 minus 18. Solving from here, negative 3 over 2 squared, we'll square the numerator and denominator. Negative 3 squared would be 9, and 2 squared would be 4. So we'll have 9 over 4. 3 times negative 3 halves. You can make each of these fractions and then multiply straight across. 3 times a negative 3 would be negative 9, and 1 times 2 would be 2. And minus 18 would stay the same. Solving from here, we have y is greater than or equal to. Getting common denominators, we can leave 9 over 4 the same. 9 over 2, we can rewrite this 4 by multiplying by 2. So we'll have minus 18 over 4. And the negative 18, we can also write with a common denominator. If we have 18 over 1, we can multiply numerator and denominator by 4. And that would give us negative 72 over 4. Simplifying, y is greater than or equal to 9 minus 18 would be negative 9, and negative 9 minus 72 would be negative 81 over 4. Taking the improper fraction, if we divide it out using a mixed number, so we can graph it, 4 goes into 81 20 times. There's 1 left over, so that would be 20 and 1/4. It is negative, so we'll have negative 20 and 1/4. So the vertex for this parabola will be negative 3 over 2, and the y value negative 20 and 1/4. The second part to graph, we can find the direction. Looking back at the original equation, we had a positive x squared, so the direction would go up. We can also find the y-intercept. If you remember, the y-intercept is the value of c in the original equation, which would be negative 18. Graphing from here. Our x value is negative 3 halves. And the y value is negative 20 and 1/4. So going down 20 spots and a little bit past, that would be negative 20 and 1/4. And the x value would be at negative 3.5 or negative 1.5. The y-intercept is at negative 18. And the direction of this parabola goes up. Looking back at the original inequality, it is greater than or equal to, which means it is a solid line for the graph. And the last part for an inequality is shading. We have y is greater than or equal to the equation, The greater than y's would be above the graph, or in this case, everything inside the parabola. And that would be the graph for the section. Second question, and last question for the section, is y is less than x squared plus 4x plus 4. Again, there are several ways to graph this quadratic equation. One method we could use is factor. If we factor this equation, x squared plus 4x plus 4, the two numbers that multiply get 4 and add to get 4 would be x plus 2 and x plus 2. Rewrite. After factoring, if you remember from previous sections, we can set these factors equal to 0 to find out the x-intercepts or solutions to the graph. So the first parentheses, x plus 2 equals 0, and the second parentheses will be the same, x plus 2 equals 0. Solving each one of these, we'll get the same answer twice, x equals negative 2. If you get the same answer twice, that means there's one solution to the graph, negative 2. It's called a double root, since the root repeats. Graphing the one solution at negative 2, that will be the only x-intercept, which means the vertex will be on the x-axis at that point. We could also do the y-intercept from the original equation, which was positive 4, and the direction goes up since we had positive x squared. Also, the inequality was less than. Less than would be a dashed line. So we'd have a parabola going through the vertex and the y-intercept, but it would be a dashed line instead of a solid line. And we had y is less than the equation. Y is less than means we want the smaller y values, everything on the bottom of the graph, which would be everything underneath the parabola. And that would be the graph for the question. Title of the last section today is Find the Solutions Using a Graph. Given a completed graph, we can find the solutions, which are again where the graph crosses the x-axis or the y value is equal to 0. First equation or first graph, we have an inequality graph. The 2 points that cross that on the left-hand side is negative 2, and on the right-hand side is positive 2. If this was an equal equation with not shaded, our two answers would be negative 2 and 2. Since the graph is shaded and the points are shaded between the 2 points, our answers will be everything between negative 2 and positive 2, which you can write as negative 2 is less than or equal to x is less than or equal to positive 2. So including the points negative 2 and positive 2, all the numbers in between are also solutions to the graph. Second graph and second equation. On this graph, it crosses the x-axis at one point, which would be the vertex, and that point is at positive 4. Since there's only one point and no other point on the x-axis is shaded, the answer to this graph would be x equals 4. And last problem for the section. We have a graph that crosses the x-axis twice. One point is at negative 3, and the second point is at positive 3. And the shading for this graph is on the left side and right side. So we want the numbers less than negative 3 and greater than positive 3. So our answer would be x is less than negative 3, or x is greater than positive 3. The graph does not include the points, so it's not or equal to, since it's a dashed line.